Antenna Discharge Unit, abbreviated as ADU, is a safety device primarily designed to protect antenna systems and sensitive electronic equipment from damage caused by lightning strikes or static electricity discharge. The ADU is connected between the antenna and ground. When a voltage surge occurs, such as from lightning, the ADU diverts the excess energy to the ground. This prevents the surge from reaching and potentially damaging the sensitive equipment connected to the antenna. The ADU typically consists of a gas-filled spark gap or a solid-state surge suppressor. Several manufacturers produce antenna discharge units. These include Alpha Technologies Components Corporation, Polyphaser Incorporated, Belden, Lightning Protection International Incorporated, which is abbreviated as LPI, and Airco International Corporation. ADU are designed with several key features. Firstly, fail-safe operation. ADU are typically designed to fail in a safe condition. This allows the antenna to function normally during non-surge conditions. Secondly, low loss. ADU are designed to minimize signal loss while providing effective protection against surges. Thirdly, compact size. ADU are designed to be compact and easy to install in various antenna system configurations. Fourthly, weatherproof housing. ADU are often housed in weatherproof enclosures to withstand outdoor conditions, ensuring reliable performance in harsh environments. Fifthly, certifications. ADU may be certified to various standards such as ANSI/TI-102/TI-222, H and UL 96, A, indicating compliance with industry safety and performance requirements. ADU find common use in several applications. Firstly, antenna systems for radio and television broadcasting. Secondly, mobile communication systems such as cellular towers. Thirdly, satellite communication systems. Fourthly, military and aerospace applications. Fifthly, industrial facilities. In more detail, let's explore how an ADU operates, the crucial function it serves, and where it finds its application. The primary function of an ADU is to safeguard electronic equipment connected to antenna systems from the destructive effects of voltage surges. These surges can originate from lightning strikes, static electricity buildup, or other transient voltage events. Without an ADU, such surges could easily propagate through the antenna system, damaging sensitive receivers, transmitters, and other components. The ADU acts as a protective barrier, diverting the surge energy harmlessly to ground. An ADU is strategically installed between the antenna and the equipment it is protecting. When a normal signal is present, the ADU remains inactive, allowing the signal to pass through with minimal attenuation. However, when a voltage surge exceeds a predefined threshold, the ADU instantaneously kicks into action. There are two main types of ADU: gas discharge tubes and solid-state surge suppressors. Gas discharge tubes contain a sealed gas-filled chamber with electrodes. Under normal conditions, the gas acts as an insulator, preventing current flow. When a surge occurs, the voltage across the electrodes rises rapidly, ionizing the gas. This ionization creates a conductive path, allowing the surge current to flow to ground. Once the surge subsides, the gas deionizes, returning to its insulating state. Solid-state surge suppressors typically employ semiconductor devices such as transient voltage suppression diodes or metal oxide varistors. These devices exhibit a high impedance under normal operating voltages. When a surge occurs, their impedance drops dramatically, diverting the surge current to ground. Solid-state suppressors offer fast response times and can handle repetitive surges, making them suitable for sensitive electronic equipment. Beyond its primary function of surge diversion, an ADU incorporates several important design features. Fail-safe operation ensures that the antenna system continues to function even if the ADU itself fails. In most designs, a failure mode results in the ADU becoming a short circuit to ground, effectively disconnecting the antenna. This prevents any further surges from reaching the equipment. Low signal loss is a critical requirement for any ADU. The ADU must not significantly attenuate the desired signal passing through the antenna system. Manufacturers employ various techniques to minimize signal loss, such as impedance matching and careful component selection. Compact size and easy installation are also important considerations. ADU are typically designed to be small and lightweight, allowing for convenient integration into existing antenna systems. Standardized connectors and mounting options simplify the installation process. Weatherproof housing is essential for ADU deployed in outdoor environments. The housing must protect the internal components from moisture, dust, corrosion, and extreme temperatures. Robust materials and sealing techniques ensure reliable performance in harsh weather conditions. Compliance with industry standards and certifications provides assurance of the ADU performance and safety. Standards such as ANSI/TI-102/TI-222, HNUL 96 specify the requirements for surge protection devices used in telecommunications and other applications. ADU find widespread use in various applications wherever antenna systems are deployed and the risk of voltage surges exists. In radio and television broadcasting, ADU protect transmitters, receivers, and other equipment from lightning strikes and other transient voltage events. This ensures uninterrupted broadcasting services and prevents costly equipment damage. Mobile communication systems such as cellular towers rely on ADU to protect sensitive electronic components from surges caused by lightning or power line disturbances. This ensures reliable communication services for mobile phone users. Satellite communication systems also employ ADU to protect ground station equipment from lightning strikes and other voltage surges. This is particularly important in remote areas where satellite communication is often the only means of communication. Military and aerospace applications utilize ADU to protect critical communication and navigation systems from electromagnetic interference and voltage surges. This ensures reliable operation in demanding environments. Industrial facilities also benefit from ADU by protecting sensitive electronic equipment from voltage surges caused by lightning, power line disturbances, or other electrical events. This prevents equipment damage and ensures continuous operation of industrial processes. In summary, an antenna discharge unit is a crucial safety device that protects antenna systems and electronic equipment from the damaging effects of voltage surges. Its ability to divert surge energy to ground while maintaining signal integrity ensures reliable operation and prevents costly equipment damage in a wide range of applications. The ADU key features such as fail-safe operation, low signal loss, compact size, weatherproof housing, and compliance with industry standards make it an essential component of any well-designed antenna system. Selecting the right ADU for a specific application requires careful consideration of factors such as surge current capacity, voltage protection level, insertion loss, and environmental conditions. Consulting with experienced professionals and reviewing manufacturer specifications can help ensure that the chosen ADU provides adequate protection for the antenna system and connected equipment. By understanding the function, features, and applications of ADU, engineers and technicians can make informed decisions to protect their antenna systems from the threat of voltage surges. Always adhere to local electrical codes and regulations when installing and maintaining ADU. Proper grounding techniques are essential for ensuring the effective operation of ADU and minimizing the risk of electrical hazards. Regular inspection and testing of ADU are also recommended to verify their continued functionality and identify any potential issues. In conclusion, the antenna discharge unit plays a vital role in protecting antenna systems and electronic equipment from the damaging effects of voltage surges. Its ability to divert surge energy to ground while maintaining signal integrity ensures reliable operation and prevents costly equipment damage in a wide range of applications. The ADU key features, such as fail-safe operation, low signal loss, compact size, weatherproof housing, and compliance with industry standards, make it an essential component of any well-designed antenna system. Furthermore, with technological advancements, ADU are becoming more sophisticated, offering enhanced performance and reliability. For instance, some ADU now incorporate advanced monitoring capabilities, allowing users to remotely track their performance and identify potential issues before they escalate. These smart ADU can provide real-time data on surge events, voltage levels, and temperature, enabling proactive maintenance and preventing costly downtime. Additionally, manufacturers are developing ADU with improved surge current capacity and faster response times to meet the increasing demands of modern electronic equipment. These advancements ensure that ADU can effectively protect even the most sensitive devices from the damaging effects of voltage surges. In addition to its technical capabilities, the ADU environmental impact is also becoming a growing concern. As the demand for electronic devices continues to rise, so does the need for ADU to protect them. This increased demand has led to a greater focus on sustainable manufacturing practices and the use of environmentally friendly materials. Manufacturers are exploring options such as using recycled materials, reducing energy consumption during production, and designing ADU that are easily recyclable at the end of their lifespan. These efforts help minimize the environmental footprint of ADU and promote a more sustainable approach to surge protection. The future of ADU is likely to be shaped by several key trends. Firstly, the increasing adoption of wireless technologies will drive the demand for ADU in a wider range of applications. As more devices become connected to the internet, the need to protect them from voltage surges will become even more critical. Secondly, the growing focus on energy efficiency will lead to the development of ADU with lower insertion loss. This will help minimize the impact of ADU on the overall energy consumption of antenna systems. Thirdly, the rise of smart homes and smart cities will create new opportunities for ADU to provide enhanced protection and monitoring capabilities. Smart ADU can be integrated into home automation systems to provide real-time alerts and prevent damage to sensitive electronic equipment. Fourthly, the increasing threat of cyber attacks will drive the development of ADU with enhanced security features. These features can help protect antenna systems from unauthorized access and prevent malicious actors from exploiting vulnerabilities. In conclusion, the antenna discharge unit is a crucial component in protecting antenna systems and electronic equipment from the damaging effects of voltage surges. Its evolution has been driven by technological advancements, environmental concerns, and emerging trends such as wireless technologies, energy efficiency, smart homes, and cybersecurity. As the demand for electronic devices continues to grow, the role of ADU will become even more critical in ensuring reliable operation and preventing costly equipment damage. By staying abreast of the latest developments in ADU technology, engineers and technicians can make informed decisions to protect their antenna systems and contribute to a more sustainable future. Selecting the appropriate ADU requires a comprehensive evaluation of the specific application and environmental conditions. Factors such as surge current capacity, voltage protection level, insertion loss, operating temperature range, and compliance with relevant industry standards should be carefully considered. Consulting with experienced professionals and reviewing manufacturer specifications can help ensure that the chosen ADU provides adequate protection and meets the specific needs of the antenna system. Proper installation and maintenance of ADU are essential for ensuring their continued functionality and reliability. ADU should be installed in accordance with manufacturer instructions and local electrical codes. Regular inspection and testing should be performed to verify their performance and identify any potential issues. Damaged or malfunctioning ADU should be replaced promptly to prevent equipment damage and ensure continued protection against voltage surges. In addition to the technical aspects of ADU, it is also important to consider the economic and social implications of surge protection. The cost of downtime and equipment damage caused by voltage surges can be significant, particularly in critical infrastructure applications such as telecommunications, transportation, and healthcare. Investing in ADU can help mitigate these risks and ensure the continued operation of essential services. Furthermore, the use of ADU can contribute to a more sustainable and resilient society. By protecting electronic equipment from damage, ADU can help reduce waste and conserve resources. They can also help prevent disruptions to critical services and ensure the safety and well-being of communities. In summary, the antenna discharge unit is a vital component in protecting antenna systems and electronic equipment from the damaging effects of voltage surges. Its evolution has been driven by technological advancements, environmental concerns, and emerging trends such as wireless technologies, energy efficiency, smart homes, and cybersecurity. By understanding the function, features, applications, and implications of ADU, engineers, technicians, and policymakers can make informed decisions to protect their assets, ensure reliable operation, and contribute to a more sustainable and resilient future. The choice of an ADU should also be integrated into a comprehensive surge protection strategy, which includes other measures such as proper grounding, surge protective devices at the service entrance, and surge-resistant design practices. A layered approach to surge protection can provide the most effective defense against voltage surges and minimize the risk of equipment damage. Finally, ongoing research and development efforts are focused on improving the performance, reliability, and sustainability of ADU. These efforts are aimed at developing new materials, designs, and manufacturing processes that can enhance the protection capabilities of ADU while minimizing their environmental impact. The future of ADU is likely to be shaped by these innovations, leading to even more effective and sustainable surge protection solutions. In addition to the technical and practical aspects of ADU, it is also important to consider the regulatory and legal framework surrounding surge protection. Many countries and regions have established codes and standards that specify the requirements for surge protection in various applications. These codes and standards are designed to ensure the safety and reliability of electrical systems and protect people and property from the hazards of voltage surges. Compliance with these codes and standards is often mandatory and can be enforced by regulatory authorities. Furthermore, legal liabilities can arise from damage or injury caused by voltage surges if adequate surge protection measures are not in place. It is therefore essential for engineers, technicians, and building owners to be aware of the relevant codes, standards, and legal requirements for surge protection in their jurisdiction. They should also ensure that the surge protection systems are properly designed, installed, and maintained to comply with these requirements and minimize the risk of legal liabilities. In conclusion, the antenna discharge unit is a multifaceted component with significant technical, practical, economic, social, regulatory, and legal implications. Its effectiveness in protecting antenna systems and electronic equipment from voltage surges depends on a thorough understanding of its function, features, applications, and implications. By staying informed about the latest developments in ADU technology, adhering to relevant codes and standards, and implementing comprehensive surge protection strategies, engineers, technicians, building owners, and policymakers can contribute to a safer, more reliable, and more sustainable future. Furthermore, the integration of renewable energy sources into the electrical grid is creating new challenges and opportunities for surge protection. Renewable energy sources such as solar and wind power are inherently intermittent and can introduce voltage fluctuations and harmonics into the grid. These fluctuations and harmonics can increase the risk of voltage surges and equipment damage. ADU and other surge protective devices are essential for mitigating these risks and ensuring the reliable operation of renewable energy systems. In addition, the increasing use of DC power in electronic devices and systems is also driving the development of new ADU technologies. DC ADU are specifically designed to protect DC circuits from voltage surges and are becoming increasingly important in applications such as electric vehicles, data centers, and telecommunications equipment. The evolution of ADU technology is therefore closely linked to the ongoing transformation of the energy landscape and the increasing reliance on electronic devices and systems in all aspects of modern life. As the demand for reliable and sustainable energy continues to grow, ADU will play an increasingly important role in ensuring the safety and performance of electrical systems and protecting critical infrastructure from the damaging effects of voltage surges. The development and deployment of ADU require collaboration among engineers, scientists, manufacturers, policymakers, and end users. This collaboration is essential for identifying emerging challenges, developing innovative solutions, and ensuring that ADU are effectively integrated into electrical systems and surge protection strategies. Furthermore, education and training are crucial for ensuring that engineers, technicians, and building owners have the knowledge and skills necessary to properly select, install, and maintain ADU. Comprehensive training programs should cover the principles of surge protection, the function and features of ADU, relevant codes and standards, and best practices for installation and maintenance. By investing in education and training, we can empower individuals and organizations to protect their assets and contribute to a safer and more sustainable future. In summary, the antenna discharge unit is a critical component in a complex and evolving ecosystem of surge protection technologies, regulations, and practices. Its effectiveness in protecting antenna systems and electronic equipment from voltage surges depends on a holistic approach that considers technical, practical, economic, social, regulatory, legal, and educational aspects. By embracing innovation, fostering collaboration, and investing in education, we can unlock the full potential of ADU and create a more resilient and sustainable world.